A sound wave travels from water into air. Its wavelength in air is shorter than in water. How do the frequency and speed of the wave in air compare with their values in water? So you've got two columns, frequency in air and speed in air. And you've got A, B, C, and D. So A is higher in frequency when in air, slower when in slower for the speed in air. For B, the higher frequency in air, same for the speed in air. And C, the same frequency in air, slower for the speed in air. And for D, it is the same frequency in air and same speed in air. Now, to answer this question, the frequency change will always be the same. So the frequency doesn't change when it goes from one medium to another. So we can eliminate A and B because the frequency is higher than air, and that is not the case. So we can eliminate A and B because the frequency will always stay the same whenever there's a change in medium. So it can either be C or D. So how do you determine which one is either C or D? Now, if the atoms are closer together, the atoms will vibrate because sound is a pressure wave. So if the atoms are closer together, that means that the material is more dense. And because in the question it says water and air. So in water, the molecules are closer together than air. So therefore the speed in air will be slower. So it's not going to be D, the answer is C. Alternatively, what you can say is that instead of eliminating A and B first, you can eliminate B and D, because you know that the speed will change. The speed will change when it goes from one medium to another. So you know that it can't be the same. So you can eliminate B and D. So it can either be A or C. And because the frequency stays the same, the answer is also C. Question 11, red light refracts when it enters glass from air because its speed changes. So you've got a diagram where the red light is coming into the glass. So air is the first medium, glass is the second medium, and the line has changed, the direction has changed. The red light is replaced by blue light. Which statement is correct about the refraction of blue light? So A, it refracts less than red because its speed in glass is greater than red. B, it refracts less than red because its speed in glass is less than red. C, it refracts more than red because its speed in glass is greater than red. Or D, it refracts more than red because its speed in glass is less than red. Okay, and then to answer this question, now you need to remember the formula that V is equal to F times lambda. So the speed of the wave is equal to the frequency of the wave times the wavelength of the wave. Now you need to remember that red light has a longer wavelength than blue. So therefore blue will have a shorter wavelength. So if you substitute the lambda into the equation above, V equals F lambda, so what happens when lambda goes down? V then goes down because F stays the same. So, and also if you have a lower lambda, meaning if the wavelength is shorter, the angle of deflection will be more. Now that is because there is more energy. If you think about the energy of the wave, now because you've got electric field and magnetic field, if you have a more energetic wave, the wave will influence the electrons in the atom. It will vibrate more because it has more energy, and so therefore the angle will change more significantly than a less energetic wave. So which one is it? All right, so if so if the blue wavelength is shorter and you're substituting into the equation V equals F lambda, so if lambda goes down, V goes down. So therefore you can eliminate A and C because it must be less. And because it has more energy, it will refract more. So number one, the speed must be less than red because you substituted the lambda as being less, and because it is more energetic. If you think about the electromagnetic spectrum, gamma rays are more energetic than radio waves. So if in a visible spectrum, the blue light is more energetic than red light. So therefore it will refract more than red. Question 16. A crowd makes a Mexican wave. A Mexican wave starts with people lifting and lowering their arms. The Mexican wave continues by people next to them lifting and lowering their arms. Why is a Mexican wave an example of a transverse wave? Part B. In the classroom, a teacher demonstrates waves using a rope. Look at the diagram of the wave. So you've got 6 meters and 1.8 meters vertically, 6 meters horizontally. The frequency of the wave is 2 Hertz. What does this statement mean? Part 2. How many seconds will it take for this wave to travel 12 meters? Show your working. Part C. Ultrasound scans are used to produce images of tissues inside the body. Now you've got a diagram, the square at the top of the diagram, and it says that the ultrasound scanner emits and receives ultrasound. And you got these lines, 4 lines, the tissue layers in the body. Ultrasound waves are emitted. The waves reflect from layers of tissue inside the body. Explain how the reflections are used to produce an image of the tissues. Part D. Ultrasound and X-rays are used to scan patients in hospitals. Complete the table to show a medical use, benefits and risk of using these waves to scan patients. So you've got 3 rows and 4 columns. Now the row for X-rays, the medical use shows up hard tissues inside the body. Example of a benefit, takes images of broken bones. And the risk, damages living cells by causing blank. What is that blank? Ultrasound. What is the medical use? What is the example of a benefit? And the risk is none. This is 3 marks. This is part D. Let's answer question 16. So for question 16, you've got a Mexican wave. So let's just say that this person is standing here. So here it is next to each other, isn't it? So that's next to each other. That's next. Now, because they are raising their arms, so the arms are being raised. So when the arms are being raised and the next person does the same thing, what do you say? So the arms are being raised 90 degrees, isn't it? So it's 90 degrees. So basically this question is about the definition of a transverse wave. So A, it's 90 degrees because the arms are being lifted perpendicular to the direction of the wave. So that's part A, that's 1 mark. So that's just the definition of a transverse wave. It travels, so the arms is being lifted perpendicular to the direction of the wave. So the direction of the wave is that direction, because it's going from next person, and because the arms are raised vertically compared to the horizontal wave, that is a transverse wave. So this is just basically the definition of a transverse wave. For part B, what is the meaning of 2 Hertz? So 2 Hertz will be 2 waves per second. So for part B, 2 Hertz is 2 waves per second. 2 waves per second. What about part C? Sorry, part 2. Part 2. All right, so it's asking you for the time it takes for 12 meters. Now, in a diagram, one wave, so in the diagram, you've got 3 waves at 6 meters. So in the diagram, it was 1, 2, 3. So from there to there, so that's 1 wave, isn't it? Is that 1 wave? So that's 1, 2, and 3, and that was 12 meters. So one wave is equal to 3 waves is equal to sorry, that's meant to be 6. Sorry, is that 6? 6 meters. So 3 waves is equal to 6 meters. So one wave is 2 meters. Okay, so 3 waves is 6 meters. One wave is 2 meters, dividing it by 3 both sides. And you know it's 2 hertz, so it's 2 waves per second. So, and it's asking you for, what's the question? It's asking for 12 meters. So for 12 meters, that's going to be 6 waves. 12 meters is 6 waves. And you know that it takes, and 2 waves is 1 second. So if you 2 waves, so it's 3 seconds, because 1 wave takes a half a second. Let's just say, so 1 wave is half a second, and you've got 6 waves. So 6 waves is equal to 3 seconds. So that's the answer. So 6 waves equals 3 seconds. All right, and then part C. This is part C. Let me rub this out. This question is about the ultrasound. Now, if you have 4 different layers, and you've got ultrasound, so let's just say that's the box, and this is the sound wave coming in. You will have a reflection coming this way, but then some of it will be transmitted through. And then after it passes through this point, some of it will be reflected back. And then remember, it carries on, and then some of it will be reflected back. So, but it gets less and less energy. So the energy gets transferred to the surroundings. In this case, to the medium, the tissue. And so here, you'll be transmitted, and some of it will be reflected back. So some of it will be transmitted, some of it will be reflected back. Now, because you have different times, so as the wave goes through and it gets reflected back, you have a time 1 that it receives. And because some of it gets transmitted, but then it gets reflected back, there will be another time, isn't it? So you get different times. So time 1 for this boundary, time 2 for this boundary, time 3, and then time 4. So you have 4 different times, 1, 2, 3, 4. So different times and different peaks. So you have different times. So number 1, you can say that you have different times, different peaks. Number 2, now how would you work it out? Now if you've got the time it takes for it to be received by the transducer, you can work out, because you know the speed of ultrasound, don't you? The speed of ultrasound is known. So you know the speed of ultrasound. And if you know the speed and you know the time, what equation can you use? Speed equals distance divided by time. So you know that distance is equal to speed times time. Oh, let's use V, not S. So you can work out using distance equals speed times time. You know the speed of ultrasound, different times, some of it gets reflected back. So different times, speed is known. Yep. So those are your 3 marks. For part D, what do you use ultrasound for? So for part D, ultrasound is used for soft tissues. Soft tissues. So that is for ultrasound. You use this for soft tissues. And what medical use is there for ultrasound? So number 1, for checking the baby, the pregnancy, or to diagnose any infection, swelling inside the body. So for to diagnose swelling or infection, diagnose swelling, infection. And for x-rays, what are the risks? What are the dangers? So for X-rays, because it can cause cancer if you have overexposure. So X-rays, you can damage DNA. So for X-ray, mutation to cells, DNA. So for X-rays, you can damage the DNA. That could cause mutation, and that will lead to cancer. I think this is a good news about waves. Gravitational wave researchers at the University of Birmingham have developed a new model that promises to yield fresh insights into the structure and composition of neutron stars. The model shows that vibrations or oscillations inside the stars can be directly measured from the gravitational wave signal alone. This is because neutron stars will become deformed under the influence of tidal forces, causing them to oscillate at characteristic frequencies. And these encode unique information about the star in the gravitational wave signal. This makes asteroseismology, the study of stellar oscillations with gravitational waves from colliding neutron stars, a promising new tool to probe the elusive nature of extremely dense nuclear matter. This news is quite interesting. This is from Wednesday, 20th of May. Astronomers spot potential first evidence of new planets being born. So here, researchers observe swirling disk around AB Uragae star, suggesting new world is forming. I'm not sure if I'm pronouncing that correctly. Astronomers believe that they may have found the first direct evidence of a new planet being born. A dense disk of dust and gas has been spotted surrounding a young star called AB Uragae, about 520 light years away from Earth. Using the European Southern Observatory's Very Large Telescope, located in Chile, the researchers observed a spiral structure with a twist near the center, which suggests a new world may be in the process of forming. The swirling disk was one of the telltale signs of the star system being born in the constellation of Euriga, the scientists said.